What's up, mathematicians? This is section 4.4, day number 2, dividing polynomials. Today we're going to divide polynomials again like we did last class, last lesson, last video, except it'll be with synthetic division. And except today it's going to be a whole lot less handwriting. The great thing about today is that, as you'll see, there's just so much less to write, and it'll go a lot faster, which is awesome. And so let me show you what this looks like. Just as a review, this is how we divided using polynomial long division. And at some point, some student or some mathematician somewhere or some person who was like doing lots of calculations just like, I've had it with all this handwriting. I don't really need to know, I don't really have to write the x cubed over and over again. I know because it's in this column that it's going to be the x cubed term. So what if I just didn't write the x cubed term? And what if I didn't write the x squared? I'll just write the 12 and the 3 and then minus negative 9 and the plus 9 over here. I'll just write. I don't want to write the x's all out. I just rather write the zeros and the 27. So what you'll see over here when we start doing the synthetic division is that we're not writing out the x's or x squared or x cubed. We're just writing the coefficients, the numbers in front. And then even more brilliant than that, I think what someone realized is that. Instead of writing the minus 3, let's change that to the plus 3, because if you did that, then you would go straight from the 1 times plus 3 to the plus 3 right here. Instead of multiplying and then changing the signs in order to subtract, what if we changed this number here? What if we change the sign of the divisor, and then all of a sudden, the negative 9 times positive 3 would give you the negative 27 directly that you're looking for. The 1 times the positive 3 give you this positive 3 that you're looking for, and then you just add. So instead of doing any subtraction at all, we're just going to change the sign once and not even worry about changing any more signs. So instead of changing these 1, 2, 3, 4, 5, 6 signs, we're just going to change this sign, and then that'll be it. Let me show you what that looks like. So over here, the only complicated thing is that you're only going to see a whole bunch of numbers, and so interpreting, you have to translate this idea, x cubed minus 12x squared minus 42 divided by x minus 3 into something that just has numbers and no x's. And that can be a little hard to get used to, but not impossible. So what we're going to do is we're going to say that instead of writing x minus 3, we're just going to change the sign of what we see. In the polynomial, we see minus 3, so we're just going to write a positive 3 here. Yeah. And then instead of a 1, instead of 1x cubed, we're just going to write a 1. And then instead of minus 12x squared, we're going to write a minus 12. And we notice, oh, wait a minute, there's a linear term missing. There should be something x, so we'll just write a 0. That's the placeholder. And then minus 42. Next, what we've got to do, so instead of writing out any x's, you'll see there's just numbers. And so what we're going to do, we're going to assume, we don't even have to write this part out either, because we assume that whatever choice we make, there's going to be cancellation. So we're not even bothering to write that down either. All we're going to do is bring down this 1 down below the line. This bottom line here is going to be representative of all 3 of these lines here. It's going to be like the result of the addition or carrying down. So we're going to bring down the 1, and then and that's going to be true every time we bring down something. We're going to be adding, and anytime we go diagonally, like you see here, we're going to multiply. So positive 3 times positive 1 gives you positive 3, and then we're going to add vertically to go down. Negative 12 plus 3 is negative 9. We're going to multiply diagonally, and so 3 times negative 9 is negative 27. We're going to add vertically. Oops. There. 0, the placeholder, plus negative 27 is negative 27. And 3 times negative 27 is, when you multiply, you're going diagonally, and then that's negative 81. And then when you add, you get negative 123. And I don't know if you can see, but we have achieved this result with a whole lot less changing of signs. There's no subtraction, and it's just a whole lot less handwriting. The hardest part about that, I think, was interpreting all of this into just numbers. And now we've got our answer, it's just numbers, and we have to back translate it into polynomials. One way to make that a little easier is to draw a little line right there to separate off the remainder. And as you can see, this is going to be the remainder, then this is going to be the constant term, the linear term, and the x squared term, the quadratic term. If you're reading it from right to left, it goes remainder, and then degree of 0, degree of 1, degree of 2. If you're reading it from left to right, you can start off, you know that this first thing is going to be 1 less than what you started with. Like x cubed divided by x is going to be an x squared. So the answer, if the question starts out with x cubed, then the answer is going to start off with x squared. In any case, there it is. There's the line. Oh, I wanted to show you also, like this 1 right here is this 1. And this minus 12 and this 3 and this minus 9 is right here. It's all the same numbers. It's just that the x squareds have not been written out, nor have the x's. You can see 0, minus 27, minus 27, 0, minus 27, minus 27. Negative 42, and minus 81, negative 81, and negative 123. They're all right here. Anyway, if you reinterpret the answer, you get this. 1x cubed minus 9x minus 27, the remainder of 123, negative 123. Let's keep going. Let's do this again. So here we see 3v squared minus 7v minus 10 divided by v minus 4. First thing we're going to do is reinterpret this v minus 4, change the sign once. There's only one sign to change in the entire problem, and you just do it right there. So now this is, what we'll call this the root, and this is the polynomial. V minus 4 as a polynomial turns into the root of 4, positive 4. And then the coefficients here are 3, negative 7, and negative 10. All right, let's drop down that 3. Multiply 4 times 3 is 12. Add to get 5. Multiply 4 times 5 to get 20. And then you add vertically to get 10. And there it is. That's all the computations you do. You just have to reinterpret now what this would look like. We're going to draw the remainder line. The last number is always the remainder. This number, then reading from right to left, to go remainder, constant term, linear term. If you wanted to read it from left to right, you would have to realize that this is a v squared. The question has a v squared, and you're dividing it by v, so the answer is going to have a 1 less than that, just a linear v term. In any case, this is 3v, should be v. 3v plus 5, remainder 10. Anyway, let's go. Let's keep going. Here, this is going to be y cubed plus 6 over y plus 2. We're going to reinterpret the divisor as the polynomial here has a plus 2, so the root over here is going to have negative 2. And so, and then we have a 1x cubed and then a 6. But I can't put the 6 right here because I'm going to need a whole bunch of placeholders. Let's see. Exponent of 3, exponent of 2, exponent of 1, exponent of 0. So I need 2 placeholders here. Kind of tricky to think about, but there it is. All right, so now we're going to add, well, 1 plus nothing gives you 1. Add vertically, and then multiply diagonally. 1 times negative 2 is negative 2. When you add, you get negative 2. And when you add, when you multiply diagonally, you get positive 4. Add 4, multiply, negative 4 times 4 gives you, negative 2 times 4 gives you negative 8. And when you add, you get negative 2. If we're going to reinterpret this whole thing, we're going to need a remainder line. And so then you can see that this is the remainder of negative 2. And this is the constant term for linear term, negative 2x, and quadratic 1x squared. The degrees go 0, the degrees go remainder, and then 0, 1, 2, which is kind of tricky to count. If you want to go from left to right, you can also have that option. A y cubed divided by y give you a 1y squared. Y squared minus 2y plus 4 with a remainder of negative 2. Let's do it again. So here, checking this, we're not going to have any placeholders, I think, and then let's reinterpret this c plus 2, the polynomial c plus 2, so the root is going to be negative 2. And then coefficients go 3, 6, negative 2. We do have a placeholder. Placeholder is going to be for the quadratic term that's missing. In between the 6c cubed, I didn't do that quickly enough. I did it too quickly. 6c cubed, and then there's 0x squared minus 2 and plus 4. All right, vertically, we're going to bring down the 3, because 3 plus nothing is 3, and then diagonally, we're going to negative 2 times 3 is negative 6. Positive 6 plus negative 6 is 0. Negative 2 times 0 is 0. 0 plus 0 is 0. Negative 2 times 0 is 0. Negative 2 plus 0 is negative 2. And negative 2 times negative 2 is positive 4. 4 plus 4 is 8. In order to reinterpret those numbers as our actual answer, we have to draw the line to cut off the remainder. And now this is going to be tricky because we got, let's go remainder and then degree of 0, degree of 1, degree of 2, degree of 3. This is going to be, the answer is going to have a 3c to the third and then minus 2 with a remainder of 8, as you can see here. If you want to go in the other direction, noting 3c to the fourth divided by c would be 3c cubed. And then we've got nothing here. So, actually writing out the answer, you don't have to write 0c squared plus 0c. It's just going to be 3c cubed minus 2 with a remainder of 8. All right, let's practice this just a few more times. Let's see. Let's do a better job this time of checking for placeholders. It goes 3, 2, 1, 0. All right, no placeholders, I think. Divided by x plus 7, that's the polynomial. The root's going to be the opposite of what I see. It's going to be negative 7. And then I go 1, 2, negative 34, and 9. 2, negative 34, and 9. Vertically, add 1 plus nothing to get 1. Negative 7 times 1 gives you negative 7. 2 plus negative 7 is negative 5. Negative 7 times negative 5 is positive 35. Negative 34 plus 35 is 1. 1 times negative 7 is negative 7. 9 times negative 7 is 2. Can you imagine how long it would take us to do all the polynomial and how much handwriting the polynomial long division version of this would have to be? All right, we have to just reinterpret these numbers as our actual answer. So I'm going to cut off the remainder with a remainder line. And so reading from right to left, this is remainder, constant, linear, x to the first power, quadratic x squared. So the answer is going to have a 1x squared. Start off with 1x squared. And we might even know that reading from left to right because this is x cubed divided by x gives you x squared. So why did I type y? It should be x's here. Okay, so x, this is x squared minus 5x plus 1 with a remainder of 2. Let's keep going. So this x plus 2 gets reinterpreted as a negative 2 here. That would be the root. That's the opposite of what we see. And then we can see here this is going to be a 1 and then an 8. And then I'm left with a whole, I need 4 numbers here. It would be the cubic, quadratic, linear, and constant. So I think I need 2 placeholders for the linear and the constant term that's not even there, not pictured. All right, let's bring down the 1. Multiply, add, multiply, add, multiply, add. Remainder line, and then we get here, you can see the remainder is going to be 24. This is going to be constant, linear, quadratic. Exponent of 0, exponent of 1, exponent of 2. We could have predicted that by saying x cubed divided by x is x squared as our first term. This is, oh gosh, why did I write y's again? That's terrible. It should be x squared plus 6x minus 12 is the remainder of 24. I'm going to keep on going. I'll see what letters I write for this last one. Here we go. So we're dividing. We got n minus 4. Let's say the polynomial is minus 4, so the root is going to be plus 4. And then we got to go, let's check for placeholders. 4, 3, 2, 1, 0. Oh, we're missing. We need another placeholder for the constant term at the very end. So it's going 1, negative 4, negative 3, positive 12, and our placeholder of 0. Let's go vertical, add. We get 1, multiply, add, multiply, add. 4 times negative 3 is negative 12. When we add them, we get 0. And then 4 times 0 is 0. And when we add, we get 0. There's a whole bunch of zeros here. All right. And it's going to be kind of tricky to reinterpret our answer. So we're going to need that remainder line to section that off. The remainder is 0. And then this is going to go constant, degree of 0, degree of 1, degree of 2, degree of 3. And we could have predicted that going from left to right because this is n to the fourth divided by n is n cubed. So let's see. Oh, I did write the letter n. That's great. So reinterpreting this is going to be 1n cubed, 0n squared, negative 3n, 0, 0 with a remainder of 0. And I can just write it, the actual answer is n cubed minus 3n. All right. One more thing. Sometimes you're going to have some preliminary work. Because I don't know if I said it, I probably didn't say it at the very beginning. You can only use this with linear divisors. You can only, like, in a previous example here, we had a divisor that was like 3x squared minus 2x minus 1. And you can't represent this entire divisor with just a single number like you can here. There's no one single number that would encapsulate all this information like we can here with just like x minus 3 turns into positive 3. It's impossible. You can't do it. So you can only, fortunately, when it comes to division, practically speaking, as a student, you will most likely usually be dividing by linear divisors, and that's why synthetic division is really great. But it's actually impossible you can't do synthetic division with something this complicated, with this complicated of a divisor. You can only use with linear divisors. So you notice here, this is linear. The highest exponent was 1. The highest exponent was 1, highest exponent was 1. It's just a linear divisor. Highest exponent of x plus 7 is 1. In each of these cases, it was only exponent of 1. So, and on top of that, we not only did they have to be a divisor, but the coefficient was also assumed to be 1. So here, what you're going to have to do, if you wanted to use, at this point it might be easier to use polynomial long division, but if you had to use synthetic division here, you'd have to first change this 2x into an x. So what you have to do is you have to actually multiply by a form of 1, like 1/2 over 1/2. It won't change the overall value of the function. They'll be equivalent. But what it will change is it'll change this 2x into an x. You have to multiply each and every single one of these terms on the numerator and denominator by 1/2. When you do, even if at the expense of doing 1/2 here, that's okay. Synthetic division can handle a fraction. These numbers don't have to be whole numbers or integers. They could be decimals. They could be fractions. They could even be, as you'll see later, imaginary numbers. Like you could have 8i here, and synthetic division still holds, still works. But what you can't do is you can't have a number coefficient out front. So this turns into x minus 3 instead of 2x minus 6. And now you can represent this divisor with this single number of positive 3. Same thing here. If you're going to divide this by this, you have to get rid of this negative 4. And so then you would multiply all the terms on the numerator and the denominator by negative 1/4 to get an equivalent version. And fractions, they're really okay. Synthetic division can handle that. This would be negative 1/4 times negative 4 is just positive 1. And 3 times negative 1/4 would give you minus 3 over, why don't you tell me what's underneath that red dot? In any case, here's some important habits. Just like before, you've got to make sure you first check for placeholders. Then you set up in descending order, like we did before. Divide by the opposite of what you see in the polynomial, like I've been calling it the root. So here that you see minus 3, you actually put on this synthetic division on the outside a positive 3. You add when you're going down and you multiply diagonally. And then lastly, you got to make sure you translate the results in descending order. And the last number is the remainder. Take care, y'all. It's been real, and I'll see you in class.